Okay, with this video, the purpose is to show you how the Merlot case can be done. The multiple regression analysis procedure can be done on Excel. Okay, so this is the wine tasting case. The Y variable is rating. Okay, this is what been given by the person who tastes the wine. So each row is one person. The person comes into the party and is offered a glass of wine, but the person who's tasting this wine doesn't know which wine it is. They just taste it and give a rating. But you do know which wine it is, so you know the price, you know where it comes from, and you also know what the person, so you know the person tasting the wine is an expert or not an expert. So the first data point, it's a $3.99 per bottle of wine. It's a French wine. And the person who was tasting it is a wine tasting expert, and that person give it a 6. So for instance, this data point, you know it's also a $3.99 per bottle of wine. It's a California wine, and the person tasting it is not a wine tasting expert, and this person give that glass of wine a rating of 5. So the rating is 1 through 10. 1 is terrible, 10 is perfect, so it's anywhere in between. Okay, so for instance, this data point, it's also a $3.99 wine. It's not from France, it's not from California, so it must be other. And so we use 2 dummy variables to represent the categorical variable, that is, where the wine is from. And there are 3 categories: French wine, California wine, and other. So the last one is represented by 0 and 0. Okay, so also this person is not expert, and this person gave it a 4 as the outcome. So I have the Y variable and all the X variables. And of course, to run a regression, step 0, the first thing you want to look at is the scatter plot matrix. So you want to look at the scatter plots. It's just that on Excel, there's more steps you need to take to get all the scatter plots. You actually need to do it one by one, and to do it on Excel, actually you do need to move your Y column to the right hand side. So whatever you're doing is X, Y scatter plot. So you insert a scatter plot. So you actually select click on the head of the column, highlight the column, X column, and keep pressing Control and highlight another column. So you have the X column and the Y column, and insert a scatter plot. So this is only one of the scatter plots. This is rating versus price. Okay, so you can do a whole bunch of this with Excel. With some other more sophisticated software, the scatter plot can be done. The scatter plot matrix can be done in one shot, but on Excel you have to do it one by one. All right. So so let's assume that you have done all the scatter plots and move forward. Let me move the Y variable back to where it is. And also, before you run regression, you need to check multicollinearity. Multicollinearity, that's just a terminology that statisticians invented to check if among my X variables are there any strong correlation among my X variables, and if there are strong correlation among my X variables, you need to clean it up before you move on, because the strong correlations among my X variables will damage your regression output. Okay, so we don't want that, so we want to clean it up up front. So we need to check if there are any strong correlations among my X variables. And now Excel, to check correlation, you go to data, data analysis, and you go to correlations, and then just select your X columns, labels in the first row. Let me just output a new worksheet. So you have the regression output for correlation among your X variables, and you basically check all these correlations to see if there's anything that's greater than 0.7 or anything less than negative 0.7. Okay, 70% is the threshold, and I think we're good here. There are no strong correlation among my x variables, so we can move on and do the regression. Okay. From the last video, we know that we want to add an interaction term to the regression model that we are going to build. So we inserted this column that is price times expert. Okay, price times expert. So you get the value calculated in this column, and once this column is created, we just treat it as a regular regression X column. Okay, so on Excel, we simply go to data and data analysis, and we find regression. Okay, first you need to select the input range for your Y variable, which is right here. We only select up to where we have data. The Excel, regression function on Excel does not allow any empty cells. Okay, so we select only where we have data. Then for the input for X variables, we select all the X columns together. Okay, that's why the X columns needs to be right next to each other, so that we can select them together as a matrix. And again, we only select up to where we have data. All right, so this is the input range. Then of course we always have labels in the first row. We'll just output to a new spreadsheet of residual plots and normal probability plots for the residuals. Okay, just say okay, and we have a standard regression output. Unfortunately, Excel, with the regression function Excel does not give you integrated residual plot of residual versus the predicted Y, the regression model or the regression line if it's simple linear regression with only one X. So Excel does not give you an integrated residual plot of residual versus the model. Regression gives you a whole bunch of individual residual plots of residual versus X, which is a bit more difficult to read, but it's okay. We can still try to figure out what's going on in most cases. In this case, it's a little bit difficult to catch the bad pattern. So the other software will work much conveniently for you. But in most cases, the multiple regression function in Excel should be sufficient to get the job done. Okay, so this is regression output, and of course, just by looking at the p-values, we know that there are some terms that are insignificant. Okay, so we know that we need to remove those terms one by one. So we probably start with the one that has the highest p-value. Okay, this is just a heuristic. You don't have to, but in most cases, this is a good idea to follow this procedure to start with the variable or the term that has the highest p-value. Okay, so on the regression output, you look at the p-value for the ANOVA test. This is significance f is just the p-value out of the regression ANOVA test, which with such a small p-value, you know that you need to reject the null hypothesis that all slopes are zero. So you have at least some slopes, some terms in the regression model that are significant. And when we look at the p-values for each individual terms in your regression model, we know that some are significant, some are not. So the results are actually consistent. Okay, and we know that these ones are insignificant at this point, and we need to remove the insignificant terms one by one. But each time we can only remove one term, because every time you remove a term, all the p-values will change. Okay, so we need to follow the procedure to remove them one by one. So first of all, let's remove French. Let's go back to the data sheet. Let's remove the French column. So of course you want to keep your original data safe, and this is your worksheet to play with. Okay, let's remove French, then go to data and data analysis and regression again. Y variable is still the same. I want to reselect my X range, which is now these four columns again that run next to each other, so that we can select them as a matrix. Okay, same settings, and say OK. So I have a new regression output. Again, by reading this regression output and by looking at the p-values, we know that still there's something that are insignificant. You can see all the p-values actually changed now. So let's find which one's bigger. So this is the biggest p-value. So let's remove expert in the next step. So go back to the data, remove the variable expert, go to data analysis, regression. Again, I need to change the input range for X columns. So there will be these ones up to where we have data. Then say OK. So we have another regression output. And by looking at the regression output and looking at the p-value, we know that the next step is to remove the variable California. Okay, so let's go back to the original data, remove California, and then go to data analysis and run the regression again. Same y variable, the x range will be these two columns up to where we have data. Okay, so now you have a regression output that all your p-values are significant. Says that all your p-values looks good. That's less than 0.05. So all your regression terms are significant. Okay, so all these betas as coefficients for your regression terms are significant, so that you can go ahead and build a model. Of course, before you can build a model, you want to take a look at the residual plot, and the residual plot looks pretty good. So you can go ahead and build a model. The R-square, adjusted R-square is about 64% in a business case like this. This is actually very good at adjusted R-squared. Okay, this is actually a very good adjusted R-squared, and we can actually use the model to do prediction. It's a pretty good prediction power. Okay, so you just code the coefficients, and you can build a model says y equal to 3.99 minus 0.016 times price plus 0.058 times price times expert. So this is the interaction term that is actually significant. So if I rewrite this as y equal to 3.99, let me combine the variable price here. So I'll say plus negative 0.016 plus 0.058 times expert. So this whole thing in the parentheses will be the coefficient for price. So this will be times price. So I'm combining the two terms. So this, from arithmetic, from basic algebra, you know that these two writings are exactly the same. These are equivalent. And now we can see that the coefficient for price, the slope on price, is actually affected by the variable expert. Okay, and we only have two cases for the variable expert. Either it's 0 or it's 1. So if the variable expert is 0, we're talking about the case for non-experts. So if this is 0, you plug in 0, this whole 0.058 times 0 will give you 0. So the slope on price will be negative 0.016. So which means that for non-expert, the slope on price is actually negative. Okay, significantly negative. The higher the price, it's probably tastes worse. Probably it's too dry, but that's what the data tells you. On the other hand, if the tasting is done by expert, you plug in expert equal to 1 here, then the slope on price becomes negative 0.016 plus 0.058, which is positive 0.058 for 2, which is very significant. So for expert, the slope on price is actually positive. An expert are trained, so you're trained to like more expensive wines. So that's how the winery industry works. Okay, so this is the winery case.